Hello again, my name is Osmanu Abubakar. I am here to use the method of completing the square to solve a problem. If you remember my first lecture, I used the method of completing the square to derive the quadratic equation. Today I am here to use it to solve a problem. After that, I'll give you a simple one to try. So today I'll use a complex problem so you understand the process. Then I'll give you a simple one to try. From there, you can have your own questions and solve and help yourself. All right, so I'll say, let me tilt my camera well. I'll say solve, what do I say? Let me write 2s squared plus 5s plus a 3 equals 0. So using a method of, don't mind my handwriting, completing the square. All right, so I'll rewrite my question here. 2s squared plus 5s plus 3 equals 0. Okay, now the first step I thought was that you need to be able to make this s squared stand alone. Okay, so you divide through by the coefficient of the s squared so that eventually s will stand alone. So this is over 2 over 2 over 2. In fact, 0 over 2 will give you 0, so I won't waste my time. Now this will kill this one. This will not give me a whole number, so I will leave it. This will also not give me a whole number, so I will leave it. Assuming this were to be a 4, then we would have gotten 4 over 2, which is 2. Then I'll write 2s. Assuming this were to be 6, then this 6 over 2 will give us a 3, so I'll write 3. But here we'll not get whole numbers, so I'll leave them. Okay, so this will be s squared plus 5 over 2s. Then I'll send the c part of the equation to the right hand side. In fact, that is what I taught in the first lecture. You move the constant to the right hand side, so it is positive. When it crosses the equal to sign, it becomes negative, so equals minus 3 on 2. Great. Now what are we going to do here? We are going to add the coefficient of x to both sides, that is the b. So we are going to add 5 over 2 to both sides. Assuming here were to be a 6 or a 4, we'll add 4 to both sides. Okay, so s squared plus 5 over 2s, then plus this coefficient, which is 5 over 2. We'll do the same thing to the right hand side, so equals 5 over 2 minus 3 on 2. All right. Okay, so as I said in the first lecture, this is the main deal. Now once you do this, whatever is here is over 2. Assuming this were to be a 6, you write it again and you divide it by 2. That is the rule. So we are going to write s squared plus 5 over 2s plus 5 over 2 all over 2. Then you square everything. That is the rule. So assuming this were to be a 3, you put your 3 here over 2, then you square everything, equals the same thing will happen here. 5 over 2 all over 2, then all squared, then minus your 3 on 2. Okay. Now we are going to add this and that, square everything. You have not done anything. If you expand, you are going to come back to the whole of this. So you are going to say that s plus whatever is here. So assuming we were to have 4 here, you add plus 4, you square everything because they are all carrying the squared. So what do we have here? But first, let's simplify this a bit so that the work will be easier. Let's simplify this a bit. So how do we simplify this? Let me do it somewhere here. Okay, assuming you have 5, let me write the same thing, 5 over 2 all over 2. How do you simplify this? You are going to say that 5 over 2 divided by 2. Is that not it? This is what I've rewritten here. I've not changed anything. So I'll come back and say that 5 over 2. Now, how do I solve division concerning fractions? You multiply, but maintaining the position of the first fraction, and you interchange the position of the second fraction. Simply put, you are finding the reciprocal of these two. So instead of division, I will say times. Then once I bring multiplication sign here, I will write the reciprocal of these two, which is 1 over 2. Okay, so I will say that. So let me simplify. So this times that will give me 5. This times that will give me 4. So all squared. Okay, so the whole of this is what has been metamorphosed into this. So I'll write 5 over 4 all squared. Now at this stage, you ignore this term. This term is not needed again, because if you expand this, you come back and get the whole of this back. You get this back. So always, whatever you have here, you add it to the first term, you square everything, equals. Now this is a term on its own, so I will simplify it completely. Now you realize that the whole of this is the same as that, so I'll put 5 over 4 all squared minus 3 on 2. What do I do here? I will write s plus 5 over 4 all squared equals. Now you simplify this completely, because this is a term on its own carrying a square. So 5, this square is going to affect everything in the bracket separately. So you are going to get 5 squared over 4 squared, and 5 squared is 25 over 4 squared is 16 minus 3 on 2. Let's simplify this. This is subtraction of unlike fractions because the denominators are not the same. So I'll pick LCM of 16. 16 into 16, 1 times 25, which is 25, minus 2 into 16. I'll get 8 times 3, 24. 25 minus 24 will give me 1 over 16. So the whole of this is equal to 1 over 16. So I'll write s plus 5 over 4 all squared is directly equal to 1 over 16. Good. Now I have to be able to clear this square with a square root. So I will say the whole of this square root, the whole of this square root, so that this square will cancel this square root. What do I have? S plus 5 over 4 equals, no, here I beg your pardon, if you open every square root, you have plus or minus sign. So let me put it here. So plus or minus is here. Okay, so equals. Now you remember this property of sets. If you have square root of a over b is the same as square root of a over square root of b. It's the same thing here. So I'll have square root of 1 over square root of 16. So this will give me s plus 5 over 4 equals, what is square root of 1? 1. Square root of 16, 4. Okay, I'll come back here and then group like terms. So I will still have my plus or minus here. I beg your pardon. Plus or minus 1 over 4. Okay, plus or minus 1 over 4. Here I'll have s equals, now this term will be pushed to the right hand side. It is positive. When it goes, it becomes negative. So minus 5 on 4 plus or minus 1 on 4. Good. Now here it is addition or subtraction of like fractions. The denominators are the same. you add or subtract the numerators, you pick one denominator. So I'm going to have minus 5 plus or minus 1 all over 4. So I have s equals minus 5 plus, so I'll pick plus first, 1 all over 4, or minus 5, then I'll pick the minus sign, minus 1 all over 4. I'll simplify each of them. So s equals, this and this will give me minus 4 over 4, or this and this will give me minus 6 over 4. S equals, this and this will give me minus 1 or negative 1, or this and this will give me negative 3 on 2. So this is my final answer. Therefore s is equal to negative 1 or negative 3 on 2. So you can use the method of factorization or the quadratic formula to arrive at the same answer, but this is the use of method of completing the square to arrive at these answers. I hope this helps. Now let me give you a simple one to try. So solve, in fact this is very simple, so I will say s squared plus what I will say 4s plus 1 equals 0. So use the method of completing the square to solve this problem following all these steps. Okay, all right, thank you once again. My name is Osmanu Abubakar. Bye bye.